Hello there. Today we will be discussing a new topic. We will be talking all about atoms, molecules, and the structure of atoms. Atoms are the smallest particles of matter. Atoms make up everything around us. It is made up of electrons, protons, and neutrons. A proton is a subatomic particle found in the nucleus of every atom. Protons are positively charged particles found within atomic nuclei. Electrons are the subatomic particles that orbit the nucleus of an atom. They are generally negative in charge and are much smaller than the nucleus of the atom. And lastly, the neutron, neutral subatomic particle that is a constituent of every atomic nucleus. Nucleus is the positively charged center of the atom consisting of protons and neutrons. It's also known as the atomic nucleus. The word nucleus comes from the Latin word nucleus, which is a form of the word nux, which means nut or kernel. Here we have a simplified diagram of an atom. Protons have a positive charge and bond together with neutrons to form the nucleus. Neutrons have neutral charge, it's neither positive nor negative. Electrons that orbit a nucleus have a negative charge. What is a molecule? A molecule is a group of two or more atoms that are chemically bonded together, that is, tightly held together by attractive forces. One example is water. It is made up of the same molecules, H2O, each having the same combination and structure of atoms, the same ratio of hydrogen to oxygen, bonded in the same way. Now let's talk about the history of atoms. The famous people who discovered atoms. From the year 400 BC, a Greek philosopher named Democritus was the first person to use the term atom, atomos, meaning indivisible. He thought that if you take a piece of matter and divide it and continue to divide it, you will eventually come to a point where you could not divide it anymore. This fundamental or basic unit was what Democritus called an atom. He called this the theory of the universe. All matter consists of atoms, which are bits of matter too small to be seen. There is an empty space between atoms. Atoms are completely solid and have no internal structure. Each atom, of a different substance, is different in size, weight and shape. In the year 1800s, John Dalton was the first to adapt Democritus' theory into the first modern atomic model. According to Dalton's atomic theory, all matter, whether an element, a compound or a mixture, is composed of small particles called atoms. Atoms are indestructible and unchangeable. Elements are characterized by the weight of their atoms. And when elements react, it is their atoms that have combined to form new compounds. In the year 1890s, Joseph John Thomson, a British physicist who is credited for discovering the electron, he used his research on cathode ray tube technology in his discovery. His experiments with cathode ray tubes showed that all atoms contain tiny negatively charged subatomic particles or electrons. Thomson was an excellent physicist and thus did not stop when he had found this negative charge. Through a series of clever experiments, he was able to predict the mass of this charge. He then found out that this charge was 1,000 times lighter than a hydrogen atom. He made a bold statement saying that this negative charge must be inside an atom. This negative charge, he called corpuscles, later became known as the electron. Thomson's atomic theory. Because of its design, this model is known as the plum pudding model. Each atom is a sphere filled with positively charged fluid. This resembles the sticky jam part of a pudding. Corpuscles, later called electrons, are the negatively charged particles suspended in this fluid. This resembles the plums in the pudding. He did not predict the movement of these electrons. In the year 1910s, Ernest Rutherford, also known as father of nuclear physics, was not convinced about the model of the atom proposed by Thomson. He thus set up his now famous gold foil experiment. He fired alpha particles, positively charged, at a gold foil. He measured the deflection as the particles came out the other side. Most of the particles did not deflect at all. Every now and then a particle would deflect all the way back. He said that there must be a positive center of the foil. He called this center the nucleus. Rutherford's atomic model, also known as the planetary model. The nucleus of the atom is a dense mass of positively charged particles. The electrons orbit the nucleus. A problem raised was, why are the negatively charged particles not attracted by the positively charged nucleus? Rutherford stated that the atom was like a mini solar system and that the electrons orbited the nucleus in a wide orbit. That is why it is known as the planetary model. In the same year 1910s, Niels Bohr agreed with the planetary model of the atom, but also knew that it had a few flaws. Using his knowledge of energy and quantum physics, he was able to perfect Rutherford's model. He was able to answer why the electrons did not collapse into the nucleus. Bohr's atomic model, also known as the Rutherford-Bohr model. Electrons orbits the nucleus in orbits that have a set size and energy. The lower the energy of the electron, the lower the orbit. This means that as electrons fill up the orbitals, they will fill the lower energy level first. If that energy level is full, or at capacity, a new energy level will begin. Radiation is when an electron moves from one level to another. Problems with this theory: electrons do not travel on a specific orbit or path. In the year 1920s, Erwin Schrödinger was a revolutionary physicist who used Heisenberg's uncertainty principle to come up with the atomic model that we still use today. Schrödinger's atomic model, also known as the cloud model. An electron does not travel in an exact orbit. We can predict where it will probably be. We cannot say for certain where it is, but only where it ought to be. The type of probability orbit is dependent on the energy level described by Bohr. Let's have a little recap. This is a structure of atom. Atom is composed of protons, neutrons and electrons. Protons and neutrons are at the center of an atom. Electrons orbit the nucleus. What is valence? The electrons, those are present in the outermost shell of an atom, are known as the valence electrons. What is iron? A charged particle is known as iron. It could be either negative charge or positive charge. The positively charged ion is known as a cation. The negatively charged ion is known as an anion. Now let's talk about atomic mass, element, and atomic number. Atomic mass. The mass of an atom of a chemical element. It is expressed in atomic mass units, symbol is U. The atomic mass is roughly equivalent to the number of protons and neutrons present in the atom. Element. An element is a substance that cannot be broken down into any other substance. Every element is made up of its own type of atom. Atomic number. The total number of protons present in the nucleus of an atom is known as atomic number. In this picture we have the element chromium, and its atomic number is 24 and it has atomic mass of 51.996. What are isotopes? Atoms that gain or lose a neutron become isotopes. Radioactive isotopes are used in medicine for imaging, such as PET scanners. Periodic table. The periodic table is the tabular arrangement of all the chemical elements on the basis of their respective atomic numbers. Can you identify the element's atomic number, mass and its symbol? The atomic number of the given element is 22. Its symbol is Ti and it has an atomic mass of 47.88. Did you get it correctly? Well done. Let's have a little recap. Atoms are made of nucleus that contains protons, neutrons and electrons. Can you tell me what elements are represented here? Use the periodic table to identify these atoms. These are the answers. Did you get it correctly? Well done. The easiest way to find the number of protons, neutrons, and electrons for an element is to look at the element's atomic number on the periodic table. That number is equal to the number of protons. The number of protons is equal to the number of electrons. Thank you for watching.